this Telit webinar, Understanding 5G Specifications and How to Avoid Costly Module Selection Mistakes. I'm Amanda Flink, the Head of Global Events here at Telit, and I will be moderating our webinar today. Before we start, we'd like to understand what best describes your interest in 5G. So if you could please take just a second to fill out the poll question, which you'll see on your screen now. To explain this topic today, I'm pleased to be joined by two Telit speakers. First, we have Jeff Clement, VP Strategic and Channel Sales at Telit. And second, Safi Khan, Telit's Regional Product Marketing Director. Today, we will discuss 5G technologies and how you can ensure your designs and selected modules will serve their intended products and business objectives. Just before I hand it over to Jeff to start the presentation, I have a few quick reminders for our audience. I would like to encourage you all to interact by posting questions. We will have time to answer some of those at the end of the presentation. Simply submit a question by posting in the box to the right of the slides. Also, please be sure to check out the resources section in the upper right-hand corner of your screen for some additional information. And finally, we will send out a replay link to all attendees at the conclusion of this webinar. And with that, Jeff, I will hand it over to you.
Thank you. Appreciate it. So as the introduction stated, we're going to provide you with some background of the current state of the union for 5G globally and how that can impact your project and decisions that you should make to help you with the best technology match up to your opportunity from a project standpoint, and making sure that there's a good thought process behind what is considered hype for 5G today versus reality. So I know everyone is eager to talk about 5G because it's in the news every day. It's been proliferating into the mobile handset market for quite some time as the global MNOs start to seed the market for 5G. And we're now moving in that direction with IoT. So whether it is really high bandwidth type of solutions all the way down to the low bandwidth solutions, 5G is coming down the path. So one of the things that we want to really focus on is what's available today versus what's coming in the future, because this is obviously going to be an evolutionary path. It's not going to be an overnight transition. And we get a lot of questions from folks about 4G and 5G, its compatibility, and where the transition points are going to happen. So as we start to launch these first generation products for 5G, there's really three different flavors. There's the sub-6, the low power millimeter wave, and the high power millimeter wave. And they all have very specific kind of use case pinpoints in the market. And understanding the difference between those and where they're being deployed around the world, especially if you have a global looking solution, is very imperative. So you're seeing, the constant news about here in North America, CBRS spectrum, the big auction that just took place, and you're hearing about sunsetting of 3G networks, and you're seeing transitions all over the globe. Especially in countries where their ecosystems are just kicking off and they're starting with 5G and not necessarily starting with older technologies, to more mature markets like North America where there's a huge transition taking place. All of this is going to be, long term. It's not something, like I said, that's just happening overnight. But we're seeing, continued improvement in spectrum efficiency, using multiple bands and aggregation across the technologies, which is increasing the overall capacity, creating higher throughput and ultimately lower latency. And I'm sure a lot of folks have heard about URLLC acronym for high reliability, low latency technology. And then, the goal obviously is to bring the next generation of use cases and to update all the existing use cases that are out there in the marketplace. So 5G networks are starting to be ramped up. It's in various stages around the globe. It's not universal yet. And each of the carriers have their own specific bands that they have from their spectrum holding today and spectrum holdings that they will purchase. So, we're seeing right now a lot of early adopters creating their initial trials and proof of concepts. Most of it is oriented around the high-speed type of solutions, so CPE, networking, video, high bandwidth requirements for the use cases is what we're seeing. You're also seeing that the age-old, replace wireline with wireless, especially where you're looking for drop-in networking capabilities, or you're looking for remote or mobile capabilities with higher bandwidth. That's where 5G is starting with these first generation of products. And so, the key here is making sure you understand where the technology is today versus what your use case is, so that you don't stumble and spend a lot of money and you can get your speed to market for your proof of concept. So some of the terms that you'll see in the future, which is not necessarily all available today, is the enhanced mobile broadband, the URLLC technology, and the growing support of private networking, whether it's a license-free CBRS, as in North America with band 48, or whether you have licensed spectrum, where some of the MNOs and some of the big utility companies have gone out and procured spectrum that's now available and made it possible. So we're in release 15 of the technology today, which is the early stages, and then there's release 16 and release 17 that you'll see coming to the market over the next 3 to 5 years. And globally, there is a combination of 4G and 5G bands, and you see here kind of by geography what they are. Whenever you see the letter N in front of the band, that denotes 5G, and sometimes you'll see LTE and 5G in the same bands, and that is all part of the madness. But unlike 3G and 4G, this complexity is growing, and it's not just a one-size-fits-all. 5G modules today are global, but even then you have to think through the business case up and down the stack from a standpoint of managing your SIMs and managing what technologies are available in what countries and what carriers. So just to kind of give you a feel for Telit, we have our 5G modules that are all the way through for FR1, which is sub-6, all the big regulatory and carrier certifications. We're also moving forward with millimeter wave, which is kind of a second wave, and you're starting to see more and more of that come together. And again, it's a longer development cycle than what you're used to with 4G. And as you go through matching up your timeline with the government regulatory and the carrier certifications for the modules, you also need to be considering the changes in the testing for end devices. For instance, in millimeter wave, the end device now has to be tested at the end device level, and that's a new change. So there's a lot of questions that you want to ask your module partner to make sure your module partner is aware of all these different nuances and is guiding you in the right direction. It's no longer just say, that is equal to this. I'm going to just use one product to get around the globe, and I'm going to get the lowest price. It's a lot more complicated from that perspective. So at this point, I'm going to go ahead and turn it over to Safi, and he'll dig it a little deeper into the technologies.
Okay, thank you very much, Jeff. Hello, everyone. So I am going to dig a little bit deeper into the specifications for 5G and help you understand how to navigate the landscape and what is different in 5G, so that you get a good idea of the new capabilities of this technology. So let's start with this cartoon or diagram that shows 3 distinct aspects of 5G, and let's cover each one separately. So Jeff touched on this enhanced mobile broadband, which is the first circle on the left. And so it's eMBB for short. Essentially, what 5G brings to the market is much higher data rates and capacity in the wireless network, and that is by means of opening up new spectrum, using this spectrum more efficiently by using a new radio. That's what the N is for. So 5G is called a new radio because the physical layer is different, it's new, as well as the capability to combine the LTE spectrum with the 5G spectrum and getting even higher speeds by simultaneously having two modems or two radios in the system joining or combining LTE and 5G signals. So you can think of some use cases for enhanced mobile broadband, and the first one that is really taking off is fixed wireless access in homes or small business enterprises. So what people or operators are trying to offer is broadband type of connectivity similar to wired speeds, so multi-gigabits per second downlink and also uplink. And so that makes this a good use case for cases where digging the ground for laying down new cabling or copper or fiber is too expensive. So eMBB will be a very good alternative to that by offering very high-speed wireless connectivity through 5G. Also, just having more capacity in the network and higher speeds allows mobile users to have basically high mobility with all of their favorite apps like streaming video or connected cameras, uplink heavy traffic, or in the context of the COVID-19 pandemic, also basically home schooling, home office, all of these activities where you're working remotely and you need fast access to your files, your corporate network, your cloud-based applications, all of that runs more smoothly over 5G using the enhanced mobile broadband use case. So that's one. Then let's move over to the middle one, ultra-reliable, low-latency communications, which is the mouthful acronym, URLLC. So this is something that 5G is promising with the release 16, where the latency, which is the delay from end to end between the wireless network, to be sub 1 millisecond. So that's really fast, which basically means that a wireless network in a, for example, manufacturing environment can allow robots and machines that are building cars or doing whatever to talk to each other very fast over a wireless network. And what that allows the company or business to do is improve their operational efficiency, where the machines don't have to be tied down because of wiring. They could become mobile. So, for example, they can carry goods from one part of the warehouse to the other while being under full control of the network. So they can be autonomous. As well as drones, for example, need very high latency, very low latency so that they can maneuver quickly. Robots, I said. And then, of course, another area where this will be very useful is vehicle-to-vehicle communication over cellular. So those are some of the aspects where URLLC comes in very handy. And then, not to forget, some very new use cases that we have yet to see that will open up in, for example, medical field, remote robotic surgery, AR and VR, where if you move your head and your headset has zero latency, perceptible to the human eye, it's very good. So all these cases are prime where URLLC will play a big role. And then finally, the third one is the massive machine type communications. That's MMTC. And what it means is that in 5G, there are provisions to have machines scale up to many thousands of nodes on the network. However, their overhead will be much lower so that they can conserve their battery and live longer life. So think of utility meters or IoT devices, wearables that are using small batteries, little tags for inventory tracking, telematics, things like that. So that is also another aspect of 5G where the system is scalable to have on one end of the spectrum these massive devices that can pump multi-gigabits data, but the same network and same technology also carries the signaling and efficiency for small devices that generate very little data but that last a very long time and need very low power consumption. So this is why 5G is a game changer, where it addresses all of these with a single technology evolving over three main 3GPP releases, which I will talk about in the next slide. So what is happening in 3GPP? So 3GPP stands for Third Generation Partnership Project. This is the standards body that basically releases the 5G specification or cellular standard specification. We all know LTE, which is 4G, so fourth generation, and 5G is now the fifth generation. It all started with 3G, so of course the name is getting old, as you know. We're now doing 5G using 3GPP, so bear with that. Now with that, the first release of 3GPP that has 5G in it is release 15, and this is basically what those three aspects that I talked about starts to bring out the first one, which is the enhanced mobile broadband. So with the initial rollouts of 5G, we get the higher speed, the multi-gigabit speed in a wireless setting, and we get new spectrum, which is in millimeter waves, which I will also talk about later. And then you get a new technology, massive MIMO, multiple input, multiple output, which means essentially that in the millimeter wave spectrum, it's completely new technology where you can use a lot of communications theory and technology in practical life by deploying basically, for example, a 64 by 64 array of very small antennas, but they are smart, where you can do individual beam forming and beam tracking from each individual antenna to focus the energy of the wireless signal towards the receiver. And that's how the magic happens and works. So this is basically what Release 15 does. It's already, there are chipsets available. Telit has the module family that we talked about, the FN980 family, which is based on Release 15. And so that's being deployed today. And then since the standard evolves, the next standard is Release 16, which we will also touch on here and there today, because that is the next big standard being released. And there are some enhancements that come with the Release 16. And basically, there are many enhancements for the cellular vehicle to vehicle or vehicle to infrastructure. So that's V2X. So autonomous cars, there's a lot of focus on making 5G low latency and more reliable for vehicle communications for safety and autonomous driving. And then the UR-LLC enhancements will come, where the network will give a very low latency response to a machine-to-machine type of communication between robots or cars or any two devices that can talk. Even in the network sense, you can do time-sensitive networking. You can align parts of the network, and it helps real-time communication. 5G in unlicensed is another aspect where you have this in LTE, licensed assisted access. So the same concept will be also deployed in 5G. As well as other features, many of them listed here. Don't have to go into each one, but the important ones are the ones I listed. And then there's some enhancements in terms of dual connectivity between LTE and 5G, more combinations, power consumption improvement, and so on. And also, 5G is also trying to promise location and positioning enhancements over cellular, where, for example, in cities where you have blockages from the satellites, you can use the 5G network to pinpoint the positioning, and you can fall back on 5G. So that's another new technology. So, and then, of course, looking out in the horizon, even further out is Release 17. So Release 17 will have its own set of features, which will include basically something called REDCap, which stands for Reduced Capacity 5G. So because 5G started on one end of the spectrum of very, very high-end devices, also there was a need to address the existing LTE devices and how to bring all of the 5G enhancements of the technology into the middle tier devices. So that's what the NR Lite or Reduced Capacity 5G will bring in Release 17. Then if you look below the track, there is the Narrowband Track, which continues. And so we all know that LTE-M and NB-IoT are basically the narrowband LPWA technologies, low power wide area licensed technologies, which can be used for meter reading or tracking, or, like I said earlier, the low power, low data devices. They are 5G ready technologies, and 5G addresses them in the same network. And so they are fully supported and will continue to have enhancements as well. So this is the overall landscape of 5G, which basically is happening in the industry. So you will see Release 15 devices. You will hear talk about Release 16. Now some of the features may roll out early, but some may roll out much later. So really that's your decision, where you have to decide whether Release 15 is okay for you for a while, or you're going to wait for Release 16. And that's the kind of decision where Telit can help you if you do a consultation, and we are leading in this 5G era. So we are here to help. Next, let's look at a use case or scenario of how the 5G network will be deployed. And here it is important to remember the physics of the spectrum. So the spectrum works in a mysterious way in the laws of physics, that the frequencies that are lower in number travel further out in distance, and frequencies which are higher in number travel shorter distance. And in terms of capacity, so the way the spectrum is allocated, the lower frequencies who travel longer are much narrower, so the operators have less spectrum bandwidth available, whereas as you go higher and higher in the frequency, since they are not really used that much, especially the millimeter wave, which is very, very ultra high frequency, travels a shorter distance, but it can carry a lot more data because the amount of spectrum available is much, much wider. So just to give you an example, in the low band, for example, the 600, 700 megahertz band, you have 20 megahertz spectrum or 10 or 5 megahertz of spectrum available. So that covers the gray area, for example, like an entire city or a metro area. And so you would deploy that, and you can still cover a large area with that spectrum. Now, as you move closer to more urban area where you have more users, you need more capacity, you can start to use more the mid-band spectrum, where you have, let's say, 100 megahertz of spectrum. So you jumped from 20 to 100 megahertz. Now you can deploy those, but these frequencies are higher, so they don't travel as far. So they will not be able to cover the rural areas, but they will be able to cover the urban area. And then finally, let's say you're in a really dense urban downtown like LA, New York, Chicago, any dense city where there are way more users in a small space. That's where you will deploy the millimeter wave, because now your waves are very high frequency, so they don't travel that far. So you can cover a smaller distance, but the users are so many that the network needs more capacity. And that's where the millimeter wave has the capability to deliver multi-gigabit speed and divide it over thousands of users, then every user's average speed goes up and they get a better user experience. They can watch their videos and upload easily and also have the connectivity. So this is basically how the 5G is envisioned to be deployed in terms of millimeter wave versus sub-6 and fallback to LTE. So this was the overall kind of a look at the specification area. And now we go a little bit even further and look at, what happens in 5G at a more tactical level in terms of what is actually happening on the ground. So just as the first introduction to some of the technologies of 5G on the ground, so I talked about millimeter wave spectrum, right? So millimeter wave just simply means that the wavelength of the frequency is of the order of a few millimeters. Now, there are few spectrum bands that are now available worldwide for 5G, and those are listed on the bottom right table, band 28, band 38, and so on. So actually, 28 gigahertz, 38 gigahertz, 60 and 73 gigahertz, respectively. So if you look at 28 and 38, those are the most common bands, actually 39. 26, 28, and 39 are the bands. And in terms of numbering, so 28 is what you might hear N257, N261, for example. And then 39 or 38 is what you might hear N260. So these bands have very high carrying capacity in terms of bandwidth, but their one problem is that, they do suffer attenuation if it's raining or if there's moisture. So the loss of the signal is much greater when there's high frequency involved, and especially around 60 gigahertz, you can see a peak. So the attenuation is even highest. So essentially, it's good to know that millimeter wave has all of the good qualities of carrying high speed data, but it comes with the challenges of basically not being able to travel very far, and also if it's not a line of sight, then also you need to have a very short distance where it works great. Now, in terms of the commercial launches, let's take a look at what's happening around the world in 5G. So in North America, we have our 4 major operators, and now 3 because T-Mobile and Sprint are combined into the new T-Mobile. And so in terms of the frequency, like I said, 28 and 39 gigahertz from AT&T, 28 and 39 from T-Mobile and Verizon. So they are operating this in, the high gigahertz range. So this is the nature of this spectrum. And of course, there also is sub-6 spectrum, which is the below 6 gigahertz. And as you can see, Europe has mostly sub-6. Sprint has a lot of sub-6. And then China has a lot of sub-6. Australia is sub-6. And then in South Korea, for example, you do have millimeter wave. And in Japan, you have millimeter wave. So there's a mix. And 5G supports both frequencies. As well as Telit has products, 5G products, that also support both of these. And with that, I wanted to show what is available in terms of evaluation, because when you're trying to make the decision about 5G and whether to do a sub-6 design or a millimeter wave design, it really depends on what your requirements are. So on the left, we have our Telit evaluation board. This has our M.2 module shown here, and then the wires connect to the antennas for sub-6, and then there is also provision, the little gold rectangles for the millimeter wave antenna. Now, this is good for someone who's savvy and knows how to work on evaluation boards with AT commands and so on. But if you just want to evaluate a 5G system without having to have the whole team to figure out how to make it work. We also support demo kits where all of the 5G is buttoned up into a end device type of a proof of concept box, which basically can connect to Ethernet or USB and then give you 5G connectivity. And this one, the one in the middle, has low power antennas, and then the one on the third one from the left has high power antennas, which means this can increase its transmit power to allow for that fixed wireless access use with an outdoor setting and get those multi-gigabit speeds for fixed wireless and enhanced mobile broadband. And then we build an antenna module which has the high power millimeter wave antennas. This is new technology, so everyone needs to spend a lot of investment to basically get this right. So to make this very easily available to customers, we have done all of the heavy lifting up front in terms of making this something that's plug and play. So this is basically the tools that you can use to help make your decision. And then last slide in this section is basically the specification of the module itself. So we have two modules available. One is called the FN980, which is a sub-6 5G module, M.2, and the other one is called FN980M, which is the millimeter wave module. And this is a specification of the bands that are supported, the interfaces, and the SIM cards, and so on. So don't have to go into details. You can get the slide and read it offline. So that's the end of this section, and I will continue into the next section before giving back to Jeff. So let's take a look at now end-to-end communications considerations and requirements. So what that means is I'm going to just touch on a few more foundational technologies in 5G that you may just hear about in terms of the acronyms, but we will give you a flavor of what they're about at a very high level without really going into too many details. So what's shown here are all the aspects of 5G that are really new in terms of technology innovation. And so let's start with the first one, which is dynamic spectrum sharing. So DSS is a new technology where the network allows the device to support 4G, LTE, and 5G simultaneously. So without going into too many details of the graph, I just want to say that the network becomes smarter and figures out in these boxes on the right, the dark blue is the 4G reference signal, and then the light blue is the control for 4G and 5G. So it spends a few of those blocks. These are basically resources. So it spends a few resources to send the control signal for this frame of data. And then dynamically, the gray and blue are intermixed. And so the receiver knows that it's receiving a 5G signal in which box. And so it knows to send that data to the 5G application, and then the blue data to the 4G, and then combine it and give it to the user application. So the Telit modules support DSS, and this helps a lot of the operators who currently have 4G deployed, but they don't want to just shut down 4G and bring 5G, because that would break all of the connections of the 4G users that they have. So the benefit of DSS is that you can continue serving your 4G users and slowly ramp up 5G users. So many of the US operators, for example, like this feature, and they are planning to deploy it so that they can dynamically support 4G and 5G users based on traffic and how many 5G users are added to the network. Next feature is non-orthogonal multiple access. This one is a little more technical, but essentially it's a communications technique, physics and communication theory involved behind it, so we don't have to go into the nuts and bolts, but essentially it outperforms other access schemes. And the way it does that is by basically canceling out the signal of the second device from the first device. So both devices are receiving the signal, but the device 1 receives it at a lower power, and the device 2 receives it at a higher power, but they're sent simultaneously. So it's a more efficient use of the spectrum and just differentiating in power. And so then by using interference cancellation, a technique of communication theory, they are able to subtract the signal of the second device, and that way recover the signal for the first device. So again, more technical than it needs to be for this webinar, but wanted you to understand what is happening under the hood. Another feature is the service-based architecture. So you know why we call 5G the new radio is because everything is new. So usually in the previous trend from 2G to 3G to 4G, a lot of the focus was to improve the physical layer, the actual, how the bits go from the transmitter to the receiver on the physical layer. Now in the new radio, the 5G, everything is new, which means even the core network, the pieces behind the base station and behind the device, how the network talks to each other and how the towers talk to each other, all of that is new. And so one of that is called SBA, the service-based architecture. And that's what's revolutionary. So basically, a lot of the processing happens in the cloud. A lot of processing happens at the IP packet layer level. So a lot of the standard IP protocol related efficiencies and network functions can be realized. So NF here means network function. And so you can see this diagram where a lot of the traffic is basically identified separately through the IP headers, and it's flexible, so it can basically address high traffic, low traffic, high latency, low latency, give quality of service to different people, and so on. So that's another aspect of 5G which is new. Next one is security. So as you know, security is an all-important feature. It means preventing unauthorized hack and cyber attacks, and it's happening more and more. So 5G has to be secure by design. It has to be secure end-to-end. Imagine if 5G is being used for this autonomous vehicle, cellular V2X, and someone hacks that network, so that's not good. Similarly, in a manufacturing environment, there have been some ransomware attacks on companies where their entire manufacturing was impacted. So this is very important. You have to have encryption. You have to have security in the design from end to end, and that's what 5G did take into account. Mobile devices, core network, everywhere where the data touches from devices into the cloud and to the edge is supposed to be secure by design. So there's a lot behind it. We're just summarizing it in one slide here, but of course there's been a lot of effort to get to this security level. And last but not least is the reduced capacity or NR Lite devices. So let's talk about this now. So 5G, like I said, came in with the big bang of multi-gigabit, 4 or 5 gigabits per second sustained throughput to an end device was unheard of earlier. But supporting such a device means it is consuming a lot of power. It has a lot of horsepower, so it's more expensive. Cost is high, but you get the very ultra high speed. But what happens if you need just an average device that needs to be on the network but wants to leverage all of the 5G technology and the ecosystem? So that's what Release 17 will bring. Will bring a reduced capacity 5G device, which will be used in wearables, smart watches, or medical devices, AR, VR, or industrial sensors, video surveillance, any kind of use case, an IoT use case where connectivity is required. So technically what it's showing in the diagram is, again, the modulation scheme will be limited to 64 QAM, even though you can go up to 256 in the other devices. And then the bandwidth will be limited to 20 megahertz, whereas you can easily go up to 100 or even more for millimeter wave. So this is going to be some of the guiding features for reduced capacity devices. But they will come with release 17, so they're still a few years out, but just know that. It will also help the transition eventually from 4G to 5G in the ecosystem. So now that kind of concludes my recap of the specification and the technical aspects. So I will hand it back to Jeff so that he can cover the use cases and business models and strategy around 5G. So back to you, Jeff.
Thank you, Safi. That was a fantastic high-level overview of all the granularity of 5G. And as you said, really what we want to kind of talk to now is kind of the use cases that we're starting to see, at least from a proof of concept perspective, or just in the Q&A phase of trying to evaluate what's going to play. But before I jump into it, I really want to emphasize that, this ecosystem of 5G, from the chipset manufacturers, the module manufacturers, the infrastructure manufacturers, and the MNOs themselves. All of this, just like every other cellular technology before 5G, has to go through an evolutionary process. 5G is obviously bringing complexities that we've never seen before in the 2G, 3G, 4G worlds, because now we have many, many more bands of spectrum that are being used in aggregation. We have merging technologies. We have huge investments that are being made by the MNOs. And this includes more than just the RF side. It also includes all the back end and all the back end structures, the business models. All of this is going through this evolution, and it will be coming in phases, as we've kind of pointed out. So as you think about your use case, I think Safi pointed it out several times, there'll be some that will be very dependent on release 16 or release 17 of the technology. So putting 5G off for a period of time makes sense, although that doesn't mean you can't do some proof of concepts with the current release 15. There are other markets that now's the time to go ahead and get started. But in the end, ultimately, 5G is going to replace 4G over the next 5 to 10 years. And it'll be by these different technologies releasing, and the pace will definitely pick up over the next 3 to 5 years. So we're anticipating that, by 2025, you'll start to see some of that transition pick up pace. And definitely over the next 5 to 10 years, really fully evolve, because the carriers need to be able to support the increased demand for their infrastructure, and 5G technology enables that. So on the screen, you see all the kind of high-level verticals, and we kind of put the sub-level verticals underneath each that we anticipate either already are using cellular, and so therefore they will continue to migrate to 5G as the technology matches up, to more and more of the newer verticals like you see in the drone space, or you see in agricultural capabilities, especially with 5G and LTE being part of the private network environment. It's not always about the MNOs. It can also be private network deployments that are now going to be supported with these newer technologies. So I'm just going to kind of go through real quick some of these examples for you with a little more granularity. But, we are seeing in the beginning of 5G, most of the OEMs that are really focusing on doing take-to-market type of products is the SD-WAN enterprise router space. So these OEMs are moving fast and furiously to integrate into their portfolio of 5G capabilities, most starting with sub-6, some starting to use low-power millimeter wave, and a relatively few that are starting to build prototypes of high-power millimeter wave. And that's, again, tied to a lot of what's capable today in Release 15, as well as the infrastructure support by the MNOs. So, but SD-WAN enterprise router, network infrastructure, IT infrastructure is where you're seeing a lot of the designs today. And as we get to Release 16 and 17, we really anticipate this picking up pace for anybody that really needs the high bandwidth, low latency features of 5G. The next space is the IoT gateways. So now you're kind of moving down the spectrum from the high-end infrastructure folks. You know, gateways start to get into just what they act as, right? They are a gateway between maybe two different technologies. Like you might have some kind of short-range RF that's doing multiple endpoint collections back to a gateway that is then doing that transition to security and video and things like that that can be done with the current 4G and 5G technologies and don't necessarily require the bandwidth and the latency issues that you see in the CPE market. Then the video streaming broadcasting, you know, this has been a growing space for cellular for quite some time, but I think 5G is really going to make this happen even faster. Again, it's going to be incremental as we move up the technology stack, but I think it's really important when you're looking at live video where you can get fast and reliable internet. You can have the fallback to 3G, 4G where 5G doesn't exist or is limited. And I think it's going to be one of those things where 5G bringing global SKUs, even though the price point is higher, there will be, especially like in broadcasting, the use case where the higher price of 5G today still makes sense from a business model perspective. Then smart grid, this is continuously seeing more and more investment, especially as you have the utilities that have acquired their own spectrum and will be going into private network build-outs, whether it be from the massive IoT around metering to monitoring live information off the infrastructure. You know, we're seeing a lot of that today with 4G, and I think 5G is just going to continue to make that easier, especially when you look at private networking capabilities. Mobile computing. Mobile computing is going to kind of be a little bit slower pace in the sense that most of the mobile computing OEMs that are building for consumer are going to be looking at sub-6 solutions to just kind of make sure they're staying in the game and having the highest end capabilities that make sense for them. But you do see a lot of specialized mobile computing, especially in the ruggedized space, whether it be for retail, oil and gas, point of sale, all these things that 5G is ultimately going to become the right solution for. We're definitely seeing that ask coming in as we're seeing those OEMs start to build their proof of concepts. So we have a link here that I want to share with everybody that is kind of where we're putting all our 5G information, and it's a great way to just kind of get in touch with us. As Safi pointed out, we're really heavily involved in a lot of projects with end customers that are taking their proof of concepts to market, but we're also very heavily into the consultative educational phase of 5G. There's a lot of time being spent by many of us just going through the business side of any of these solutions to match up the technology to what the expectations of the solution outcome will be and what makes sense from a timing perspective, because there will be a lot of changes in the hardware and firmware and software layers of 5G over the next 5 years in particular. And having that timing and that planning ahead of time can save you tremendously on the cost of your development cycle, especially when it comes to certifications and what you're going to do from a global perspective versus a regional perspective. All those kinds of things are very important. So I want to kind of close there.
Thanks, Jeff and Safi. Really great information here. Before we get to the questions, I am going to drop one last poll for our audience. If you'd like to have one of our experts contact you directly, please respond here on the poll that you see on your screen and someone will reach out. We now have time for a few questions, and there's still time to ask a question, so please do submit using the box and we'll do our best to cover it in the time we have left. All right, first question we've got here. Could you please specify the 5G frequencies in the millimeter wave band?
Sure, I can take that one. This is Safi. So as you may or may not know, so 5G is defined in the sub-6 band and the millimeter wave band. So these are two separate frequency ranges in which the 5G technology is defined. So sub-6 just means below 6 gigahertz frequency, which is similar to the 4G and LTE frequencies that we are all familiar with. What's new in 5G is something called millimeter wave band, and it just means that the wavelength of the frequency is in the order of millimeters. As you know, when you go higher and higher in frequency, the wavelength gets smaller and smaller. So in the millimeter wave band, 3GPP has defined 3 or 4 major bands which are used globally. And at a very high level, without the actual frequencies, I'll just mention that this ranges somewhere between 24 gigahertz all the way up to about 39 gigahertz. So in this high frequency range, the advantage is that the bandwidth is very wide, so you can have a much higher capacity data. So the data speeds in these bands are extremely high. However, the distance that these waves travel is smaller than the lower frequencies. So to answer the question, there's a band called N258. So it's we use N because it's the 5G new radio. So N is for the NR. So N258 is roughly in the 26 gigahertz range. Then we have N257 and N261. These two bands are in the 28 gigahertz band range. And finally, we have N260 and N259, which are in the 39 gigahertz range. So together, these 4 or 5 bands are the ones where operators are paying for the license for the spectrum in these bands and then deploying 5G networks.
Great, thanks, Safi. Next question we've got, when will Telit 5G modules support eSIM technology?
Okay, Amanda, it's Jeff. I'll take that. The Telit 5G modules today will support eSIM technology. We will do that on a custom SKU basis. So if a customer would like to have the eSIM mounted on the module, we'll work with them to designate who their eSIM provider is and then move forward with a custom part number and deliver that. But it's always important to understand that an eSIM is the physical SIM, the embedded SIM itself. And a lot of people get that confused with software-based SIMs. That's still down the road, but our modules will be able to support both an external SIM, an eSIM, and long-term any software-based SIMs. So that is available today.
Great, thanks, Jeff. Next question I've got here. Can you give a quick summary about the main delta between 3GPP Release 15 and Release 16?
That's a great question. I can take that one. So 5G really evolved out of mainly Release 15 from 3GPP, and it introduced all of the concepts that we are familiar with now, such as the new spectrum that we just talked about, the millimeter wave, the massive MIMO, which means up to 64 by 64 antennas. So we have these really tiny antennas with millimeter waves. And having lots of them, doing some smart beamforming and beam tracking. And then the network also became smarter with network slicing and this standalone and non-standalone mode. So these are all of the existing release 15 features. So I'm just repeating them so that we know the baseline use case, which is the enhanced mobile broadband, which is fixed wireless access using 5G. Now, when we talk about release 16, this is the next standard that is getting out in the market, hopefully in the next few years. And in release 16, there are a few key new features or main deltas that people are interested in. Mainly, one thing that they are promising is ultra-reliable, low-latency communications, which is a long acronym, and it's called URLLC. And with this feature, what they are promising in the network is an end-to-end delay. Latency is basically the end-to-end delay in responding from the transmitter to the receiver to be under 1 millisecond, which is quite challenging, but the standard allows that. And this would allow many new use cases such as machine-to-machine operation and robotics and augmented and virtual reality and so on. So low latency is one of the main features of release 16. Another feature is that 5G will also be able to operate in unlicensed and shared spectrum in the Wi-Fi frequency range. So it's called NRU, or New Radio in Unlicensed. So we will also be able to operate 5G in a unlicensed spectrum, just like 4G can also operate, called LAA. Then there are many other enhancements such as cellular V2X, so vehicle to vehicle or vehicle to network or vehicle to infrastructure, which is all those three things combined is called V2X. So in 5G for autonomous driving, there are many new enhancements for vehicle to vehicle and network infrastructure communications. As well as they are thinking of trying to use the 5G technology for positioning and location. So that will also either make it in release 17, but it's also something that's being studied in release 16. Moving down, then also there are some new millimeter wave bands that they are thinking of opening up, such as ultra high frequency above 52.6 gigahertz. So that's more like getting close to 60 gigahertz. So that will be a release 16 feature. And then there's also some enhancements in the MIMO configuration, and then self-organizing networks. And then there are some other improvements in the standard, just the basic, more efficient, lower power, so power improvements, and then many more combinations of dual connectivity between LTE and 5G, or even newer connectivity could be between the sub-6 5G and the millimeter wave 5G. So FR1 plus FR2, which is sub-6 plus millimeter wave connectivity. So those are the essential things coming in release 16.
Great, thanks so much, Safi. Next question I've got here, where does the responsibility for module selection lie? Is it with the specific business or industry or the network providers?
Good question. This is Jeff. I'll answer that. The key is that module OEMs like Telit go through the network provider certifications. And so the network providers provide kind of a guidance in the sense of requiring certification be met. Once a module is certified, then the end customer, that is the OEM, ODM, doing the actual design, will go through the selection process of which module that they would like to select. Now, there are obviously going to be some parameters that are very important to different businesses or industries. There are different grades of modules. We usually lump them into commercial and industrial grade. which deals a lot with the temperature ranges, also the ruggedness of some of the components in the modules. But the underlying chipset from the silicon provider remains the same. It's really all about how it's packaged, both in form factor and temperature range and durability. So you will see a trend of a particular type of module from a standpoint of which LTE or 5G category it is and what form factor it comes in, whether it's an LGA down on the board or whether you see a mini PCIe or an M.2 form factor. So there will be sometimes a trend in a particular industry just because there's commonality between OEMs and how they build their end products.
Thanks. And Jeff, I think this next one may be for you too, as sort of an add-on to what you just answered. What is the greatest hindrance in selecting the right modules? Is it the specifications or the lack of knowledge on the business benefits being targeted?
That is a huge issue right now with 5G in particular. It has always been there in cellular in general when you have to weigh the capabilities of the cellular networks versus the use case and making sure that you understand power requirements, throughput requirements, latency issues, design issues, deployment issues, support issues. All those things go into selecting the right module. With 5G, the biggest hindrance we're seeing today is just the total lack of understanding of the 5G technology in itself, coupled with a lot of the hype that you see from the marketing side of the industry, which is way ahead of the curve versus the technology. And so first understanding what it is you're trying to accomplish in the use case, and then matching that up with the technologies that are available today, but will be, as Safi's pointed out, as we go through release 15, 16, and then 17, you're going to see continued updates to the existing releases, as well as more and more feature functionality that if you were to go to end state, as many years down the road of evolution of the technology. And so being able to know all that and translate it back to what MNO you're going to operate, or is it a private network? And will you have the need for 4G or 3G fallback, and how long, and what your design costs are? It's a very complicated web, and making sure you get all the right information from a trusted partner is very important.
Great, thanks, Jeff. Next question. Will I have to replace my current 4G LTE equipment to deploy 5G and IoT?
I'll take that one too. No, 4G LTE equipment is going to be here for the long haul. And what I mean by that is, next 7 to 10 years, maybe longer. There's too much investment in the 4G network by the MNOs. And 5G in its early phase is using the 4G infrastructure as the backhaul. There's going to be a long roadmap for the MNOs to deploy both sub-6 and millimeter wave across their network footprints. And, potentially it could be years and years before they get to the point where they can say, okay, a 5G standalone device is capable of migrating anywhere on the network without relying on 4G. Now, there's one caveat to what I'm saying, and that is if you're going to move from 4G to 5G, you will probably need to do some kind of design change to your product, whether it be for the power requirements, the antenna requirements, or just the board configuration. And it depends on whether you're doing sub-6 or millimeter wave. And we're more than glad to take calls and really dive into that topic, because a lot of customers are looking at their 4G designs and just saying, I'll plug in a 5G module and be off and running. It's not quite that simple. It's definitely a little more complex. But what you've already deployed or what you've already designed with 4G modules today and what's currently being sold are very valid and going to be around for a long time. So you should be able to get reasonable life expectancy. Now, we do see some industries, I use utilities as an example, where they like to have 10, 15-year life cycles for infrastructure deployments. That's probably not likely with 4G, but at the same time, 5G is not ready for prime time yet to totally replace it, because things like true massive 5G IoT is not until we get into the latter part of release 16 and even parts of 17. So we got a lot of transition period, and 4G is good to go for quite some time.
Great, thank you. I believe that's all the time we've got for today. Please be sure to check your inboxes in the coming days for the replay link of this webinar. Thank you to Jeff and Safi for a great presentation today, and thank you to all who joined us.